Some information about me. I wrote my first line of code in Dart around 2019. Previously also played a bit with web and other web frameworks, mostly with Xamarin. In my Xamarin times, I had hated the fact that my app looked different on iOS and Android. So when I discovered Flutter, I knew that's the framework that I want to use. I love the fact that I can create something once, and it works great on all platforms, while adapting with platform-specific behavior like scope physics, for example. And before we start, you can get this presentation and all my social media if you scan this QR. It will be also at the end of this presentation, so you will have another chance to scan this QR. And what this presentation is and isn't about. I won't turn you into a designer. Well, it would be awesome if everyone could be a great developer and a great designer at the same time. That's not what I want to achieve today. I want to focus strictly on two cases. Implementing the UI that you get from your designer, and how to make something usable when you don't have a designer at all. And it's not a deep dive. I didn't intend to, but in some cases I may have gotten a bit carried away. The core belief that I want to defend today: the key to making better UIs doesn't lie in technical complexity, but in suitable use of simple concepts. I believe that to make your apps better, you first have to learn what's possible, so then you can apply it in a real project. Our agenda for today: I decided to group everything by effort. Stuff grouped as easy is something that can be achieved with around 3 lines of code. Medium requires you to think a little bit about what you want to achieve. And last but not least, hard may require upfront preparation and thinking about it before you write your first line of code. That's the Figma design that we will base today's presentation on. There are 3 screens, as you can see. First one is home screen. The second one is our image viewer with a high quality image. And the last one is a snack bar at the top. I will come back to these screens later. Let's get started. First topic, animations. Linear animations are a default, but these animations are smooth only for computers, not for end users. When you don't care, I would consider defaulting to something else. For example, is in-out curve. That's my rule of thumb. And here is a comparison. If you don't know what I'm talking about, that's linear animation with constant time. Like with time, it has the same value, and other curves like change its value in time. And here's a comparison. Can I? Oh no. Can I? No. Amazing. There's my cursor. So when you have linear animation, it has constant time. It's like when it goes down, it will go by the same amount, by the same. It will go down with a constant speed. Is in out, for example, it will slow down at the very end, and is in out back actually jumps a little bit. It goes down and then it comes back. Here are all the curves. You can go to the documentation and check all of them. There is a comparison, there are images. And I also have examples of different places where you can specify the curve. The first one is animated switcher, which animates between widgets. There is also transition builder. This one is from a dialog. And next I have an example from scroll controller. It accepts a curve when using the animate to method. And the last one may be useful when you are working on custom widgets. You can call transform on the curve to get its value. First bonus, you can also create custom curves. To create a standard custom cubic curve, you just specify 4 values. And besides cubic curves, there are also curves that allow you to alter existing curves. Here is a comparison. I will just play it in a second. So sawtooth animates like you pass a parameter here, and it repeats the same curve the number of times. Interval allows you to specify begin and end, so it will delay and end the animation faster. And split is my favorite. It actually allows you to combine two animations. Besides standard curves, there are also physics-based animations like spring and gravity simulations. And there are some helpful packages for physics-based animation, like for example Sprung, Motor, and Heroine. But moving on, shapes. Starting from Flutter 3.32, there is an implementation of super-ellipse, spherical shape. There were some implementations also before, but each of them was lacking in one way or another. So having it natively in Flutter is nice. Sphерicals are a core part of the iOS design philosophy, and without them, your app feels like it was bought on a Chinese marketplace with cheap novels. And for Flutter 3.32, super-ellipses are supported on iOS and Android. And on other platforms it has a fallback. Here's an example of a usage. You can pass rounded super-ellipse as a shape into your shape decoration. And you can also clip content with clip super-ellipse. Next shape, I mean not really shape, but related to shapes, is balanced border radius, something frequently overlooked. If you put a square that has a border radius of 20 inside another border radius of 20, it will actually not be really equal. If you look to the other picture, it looks equal. And yeah, that's the comparison. And here is a sample implementation on how to achieve that. Like that will look. You have to compute the nested radius value. And you can probably do it in like a bunch of different ways. That's just one implementation. And last one, that's marked as low effort, text distribution. And how often do you have an issue with your text widths that should be like vertically aligned, but there is something wrong with them, and you end up adding like one pixel padding at the bottom? And the answer is probably text distribution. Here I have an example of text style with height set to 1.7, and here is the proportional. You can see it, but it's there. And the other one is like aligned vertically. And it's good to know that proportional is a default value if you are on an outdated version of Flutter material, or if you create a custom design system. Next, we go into a slightly more advanced territory. OKLAB and its cylindrical counterpart OKLCH makes colors look prettier and gradients are smoother. 3 coordinates. Here is a simplification here. It's actually called chromaticity, but the idea is mostly the same. And also, LAB and LCH represent the same color gamut, but one represents them linearly and the other one cylindrically. So that's why they may be used interchangeably. And LCH stands for lightness, chroma, and hue. It's not really used in Flutter, but it's an introduction to our second color space. HCT. HCT is a color space developed by Google in order to fix shortcomings of LAB. It stands for hue, chroma, and tone, and has an out-of-the-box support in Flutter with a package that is pinned to Flutter version. Since HCT colors look more alive, you can use gradients based on that color space with a Nikodem developed package called Enhanced Gradients. Okay, you can see anything at that image. Okay. You have to trust me that the one on the right looks better. And as we talked about gradients and nonlinear curves already, let's now talk about nonlinear gradients. You may have already noticed that gradients have a visible cutoff point. It's somewhere here. You have to help me again. You can later download this presentation, and it's there. Okay, so you can achieve an easing gradient in Flutter with a class more or less something like this. You can write, of course, a variant that is constant, but that will be more code. And last group of topics in the medium effort category, layouts. Since in Flutter we don't have to deal with concepts like client-side rendering or like server-side rendering and hydration, layout shift is not such a big problem, but it can still happen if you have images or skeletons. In this case, for example, a user may want to repost something, but after the image loads, everything would like go down, and they would actually click on an image instead of like the repost button. In order to avoid that, you can set aspect ratio on your images and send it to the app along other data from your backend. Next thing, padding of horizontally scrollable lists. I have a video for this one. It should be quite clear what I mean. As you can see, here is it's like clipped here, and this one isn't clipped at the edges. And that's one issue that I often see in Flutter apps. And the last one is responsive scrolling. It affects mostly devices with larger screens, like tablets and computers. You may be tempted to use constraint box, but it can result in dead zones on the left and right side of the screen. Here is an example. Like if you have something in the middle, like this part won't scroll. You can't scroll here. So to fix that,
you have to use either layout builder and pass padding to your lists, or you can use Silver cross-axis constraint from package Silver tools. And the last part is optimistic UI. Let's start with some basics that are mentioned during almost every meetup and conference. Users' actions should be instantaneous. They click on a button and the post is liked. You can handle that request in the backend without any delays with the user. You can implement caching and show state data while loading. And you may think, but I can do that in my case, for example, right? But Revolt does that with account balance, so you probably can do it as well. What I want to talk specifically today is loading images. Network images can take quite some time to load, so there are some strategies to mitigate it. For example, using blur hash. First one doesn't use any image, any placeholder, just a tag background, where the second one actually uses blur hash. So as you can see, you have this colorful placeholder. Blur hash is a 20-30 character long string that can be stored in the database. And then on the client side, it can be used as a placeholder. There's also this thing called FunHash, but it has limited support for Flutter. I mean, there are packages, but each of them has 50 downloads and was updated 2 years ago. So I would say the support for it is limited. And the second case that I want to cover is loading high-quality images. As you may know, once you load an image in Flutter, it's cached by default. You actually have its painting bindings, and there is image cache inside that instance. And you can actually extract images from that image cache. You can use that mechanism in order to, for example, first show low-quality images, and then show a high-quality variant when it's loaded. Here we have a class that extends an image provider. We accept some URLs, scale, and headers. We obtain key that's the same behavior as in the Flutter framework, and then we load an image. Inside that load image, we just map it to network images. We check inside our image cache whether we have any of those images cached, and then we return the completer. And this completer actually it loads each of those images. And first it shows cached image, and then it loads network images one by one. And returns the future at the end. And here's a video comparison. I'll play it one more time. So as you can see, there's no animation on the left. It just appears. There's also a loader, and the animation is linear, so the user experience is not that great. On the right, we have a blur hash, so the user knows that there's an image. It also shows a previously cached version of that image, so we don't have that loading at all. It just changes it to a higher quality variant. And also, Our snack bar, as you can see, is in out back, so it feels like more natural. And having said all of this, I hope that at least some parts of the presentation are useful for you. And if there is something that I want to remember from this presentation, is the approach that is behind each point. You don't want your users to just scroll through the content, you want them to embark on a journey through the experiences that you have to offer. And thank you very much for today.